All right, so we were working on section 311. In the previous video, I had gone over problem number 1. We are talking about related rates, and that's when you are given multiple rates in one particular problem, and your job is to use the information given to determine another unknown rate. Okay, so I'm going to be starting off here with us again. On a new problem, I'm going to be doing this problem number 2 about the area of a rectangle. At the moment, and again, when I see this word moment, that tells me that I'm dealing with time, okay? That time is going to be my independent variable. Its width is 15 inches, and its length is 9 inches. The width of the rectangle is increasing at a rate of 3 inches per minute. I know that's a rate because it says the word rate. It also is comparing 2 units, inches per minute. While its length is decreasing at a rate of 2 inches per minute. Again, I know this is a rate because it says the word rate, and also it says inches per minute. It's comparing 2 units, okay? At this moment, so again, there's that word moment or time, right? At this moment, is the area of the rectangle increasing or decreasing, and at what rate? So again, my job is to determine an unknown rate. Okay, so my first thing I should do is create some variables. And again, I'm going to be dealing with time. Time is indicated by at the moment. When I'm looking at rate, I also notice 3 inches per minute. I'm dealing with time, and time is in minutes. Okay. It's asking about the area of the rectangle. And again, all of this is with respect to time. So A of t is going to represent the area of our rectangle. And it's going to ask about the rate of that area. And so I'm going to be looking for a prime of t or dA dt, however you want to look at that, okay? It also talks about the length. And so again, it's the length with respect to time. At a particular moment, the length is 9 inches, okay? And so I'm going to write that as L of t, the length with as a function of time. And it also talks about the width. So again, I'm going to write this as W of t. This is the width as a function of time. In other words, it says at a moment, the width is 15. So everything is relative to time. Now, in this particular case, you are not given a formula. You get to come up with a formula on your own. And the area of, it talks about whether or not the area is increasing or decreasing. And so if you recall, the area of a rectangle, and I'll say A of t, is equal to length times width, right? So you've got this L function, length times width. And again, I'm doing all of this of t. It's with respect to time. Everything is occurring with respect to time. And it's asking me about, at this moment, is the area of the rectangle increasing or decreasing? At what rate? Well, if the area is increasing or decreasing, I'm looking to determine if the derivative of the area of A prime is positive, that means the area is increasing, or if the derivative of the area, A prime, is negative. That means the area is decreasing. So this goes back to the first derivative test that we've been talking about. At what rate means I want to know what numerical value, at what rate is that area increasing or decreasing. So if we're talking about a rate, we must find a derivative. Okay, so if I'm going to take the derivative of the area, I'm going to take the derivative of the area with respect to time, right? T is my independent variable. And I'm taking a derivative of a product, which means I get to do a product rule. Okay, so the derivative of A with respect to t, that's A prime, or you can write dA dt, doesn't matter to me, A prime of t. And then I get to do the product rule. Okay, derivative of the first function, that's L prime of t, okay, times the second function plus the derivative of the second function with respect to t times the first function. Sorry, I'm out of space. Let's see if I can squeeze that on here. There we go. Okay. And again, notice that I'm writing L prime of t. It's the derivative of L with respect to t. L is not the independent variable. The derivative of L is L prime. Now, I know information, okay? I have information that I can substitute in, right? I mean, I don't know what the rate at which the area is changing is. I don't know that. That's what I'm trying to find. But I do know the rate at which the length is changing. And the rate at which the length is changing, it says it's decreasing, that's negative, at a rate of 2, okay, times, I know the width at this particular moment. The width at this particular moment is 15, okay, plus, I know the rate at which the width is changing. It says the width of a rectangle is increasing, that's positive, at a rate of 3. And I know the length at this particular moment. It says the length is 9 inches. Okay, so I know enough information that I can answer this question. Let's see, this gives me negative 30 plus 27. The area at this particular moment, again, I don't know what the moment is. I don't know what minute we're at, and it doesn't matter. It's just saying, hey, when the width is 15, when the length is 9, what is the rate at which the area is changing? And that area, the rate at which the area of changing is negative 3. Now, I should always go back and put a label. And remember, when you're talking about these labels, I'm given inches per minute. Hopefully you can see I'm circling that here. But I'm asked about area. And when you're asked about area, the label on area is units squared. So I actually have inches squared per minute. And then I have to go back and answer the question, is the area increasing or decreasing? Well, the area is decreasing. At what rate? Well, it's decreasing at 3 inches squared per minute. I don't need to say at negative 3. The decreasing takes care of the negative part. Okay, I'm going to pause and create another video for the next round.